For centuries, humanity has gazed at the sun with wonder and fear, recognizing it as the life-giver of our solar system. But today, we are no longer just observing from afar. We are embarking on the most daring mission in NASA's history, a journey to actually touch the sun and unlock the secrets held within its fiery atmosphere. This is the Parker Solar Probe, a robotic pioneer named after the legendary astrophysicist Eugene Parker. It is the first NASA spacecraft named after a living person, designed to solve the mysteries that have baffled scientists for decades, specifically, why the sun's outer atmosphere is hotter than its surface. Launched in 2018, this mission represents the pinnacle of human engineering. To reach the sun, the probe had to do more than just fly straight. It had to perform a complex cosmic dance, using the gravity of Venus to bleed off orbital energy and spiral closer to the solar heart than any object before it. Gravity assists are the secret to this mission's success. By swinging past Venus 7 times over the course of 7 years, the probe incrementally tightens its orbit. Each pass brings it closer to the solar corona, the region where the solar wind is born and accelerated to supersonic speeds. How does a spacecraft survive the heat of a star? The answer lies in the thermal protection system, a 4.5-inch thick heat shield made of carbon-carbon composite. This revolutionary material allows the instruments behind it to remain at a comfortable room temperature, while the front face endures nearly 2,500 degrees Fahrenheit. The core mystery is known as the coronal heating problem. While the sun's surface is a scorching 10,000 degrees Fahrenheit, the atmosphere above it, the corona, reaches millions of degrees. It defies logic, like walking away from a campfire and feeling the air get hotter the further you go. Parker's mission is to enter this corona, the very region where the solar wind transitions from a subsonic flow to a supersonic blast. By sampling the plasma and magnetic fields directly, scientists hope to understand the mechanisms that drive this incredible acceleration and heat the corona to such extremes. Speed is another record the Parker Solar Probe has shattered. At its closest approach, it travels at 430,000 miles per hour. At that speed, you could fly from New York to Tokyo in less than a minute. It is officially the fastest man-made object in the history of human civilization. As it approaches the sun, the probe enters the Alphen point, the critical boundary where solar particles officially escape the sun's gravity and magnetic field to become the solar wind. Passing this point means we are finally in the sun's home territory, sampling the star's atmosphere directly for the first time. Communication during these close encounters is impossible. The sun's intense radiation creates a wall of interference, leaving the probe to operate entirely autonomously. For days at a time, the team at the Applied Physics Laboratory can only wait and hope that the spacecraft's autonomous systems keep the shield aligned. The instruments on board are designed to endure. The Solar Probe Cup, or Faraday Cup, peers around the edge of the heat shield to catch the solar wind. It is made of high melting point materials like tungsten and sapphire, ensuring it doesn't melt while it measures the flow of ions and electrons. Early data from the mission has already revealed switchbacks, sudden reversals in the sun's magnetic field that whip the solar wind into a frenzy. These discoveries are reshaping our understanding of how stars lose mass and how magnetic energy is released into the surrounding space. Why does this matter to us on Earth? The solar wind and solar flares can trigger geomagnetic storms that have the power to knock out power grids, fry satellites, and disrupt GPS and communication networks. Understanding the sun is a matter of protecting our modern way of life. Eugene Parker first theorized the existence of the solar wind in the 1950s, a concept that was initially met with skepticism. Decades later, the probe bearing his name is proving his theories correct, marking a poetic bridge between theoretical physics and the reality of deep space exploration. As we move into 2024 and 2025, the probe is entering its final, most dangerous phases. Each orbit is tighter, each pass faster. We are now entering the perihelion, the point in the orbit where the spacecraft is closest to the sun's center. barely 3.8 million miles from the surface. The timing is perfect. The sun is currently reaching its solar maximum, the peak of its 11-year activity cycle. This means the probe will witness massive solar flares and coronal mass ejections from a front row seat, providing unprecedented data on these violent solar events. Precision is everything. If the heat shield tilts by even a few degrees, the entire spacecraft would vaporize in seconds. The probe uses limber sensors that detect when sunlight hits the body and automatically fire thrusters to move back into the protective shadow of the shield. The data transmitted back is a goldmine. Hundreds of gigabits of information regarding particle density, magnetic flux, and plasma temperature are being analyzed by thousands of scientists worldwide, rewriting the textbooks on stellar physics in real time. This mission isn't just about our sun. By understanding the physics of our star, we learn about every other star in the universe. We learn how stars interact with their planets, how they create habitable zones, and how they evolve over billions of years. We are now seeing the dust-free zone. Scientists hypothesized that near the sun, the intense heat would vaporize space dust, creating a clear region. Parker has confirmed this, showing us a pristine environment that hasn't been seen since the dawn of the solar system. The final approaches will be the most harrowing. The probe will endure radiation levels and heat that were thought impossible for a man-made machine to survive. It is a testament to human curiosity and our relentless drive to explore the unknown, no matter the cost. Parker's legacy will live on for generations. The technologies developed for this mission, from the heat shield to the autonomous navigation, are already being adapted for future missions to the outer planets and beyond, paving the way for the next era of discovery. Every image captured, every magnetic field line measured, brings us closer to answering the fundamental questions of our existence. Where did we come from? How does our star sustain life? And what is the ultimate fate of our solar system? We are witnessing the sun not as a static ball of gas, but as a living, breathing, and dynamic entity. The corona is a turbulent ocean of plasma, and the Parker Solar Probe is the first vessel to navigate its treacherous waves. As it completes its final orbits, the probe will eventually run out of fuel. Its thrusters will no longer be able to keep the shield pointed at the sun. In its final moments, the spacecraft will break apart and become part of the very atmosphere it was sent to study. But even after its physical end, the Parker Solar Probe will have changed everything. It will have proven that we can reach out and touch a star. It will have shown us that with enough ingenuity, the most hostile environments in the universe can be explored. The triumph of Parker is a triumph of the human spirit. It is the result of decades of planning, thousands of hours of labor, and the unwavering belief that no mystery is too great to solve if we have the courage to look closer. As the mission reaches its historic conclusion, the world watches. We are on the verge of a new understanding of our place in the cosmos, guided by a small silver probe that dared to fly into the fire and returned with the secrets of the gods. This is more than just a scientific mission. It is a voyage of discovery that defines our era. NASA's Parker Solar Probe has not only touched the sun, it has touched the future of humanity, lighting the way for all the explorers who will follow. The sun is no longer